Okay, we've got the quadratic formula here that we're working on, and like I said in class briefly the other day, I did a lot of factoring and a lot of completing the square when I was in high school, and then they came along and said, "Oh, by the way, you can take something like this, 2x squared plus 6x plus 1 equals 0, and you can actually solve this without doing either of those two methods." Which kind of made me a little upset because I was like, are you kidding me? I did all that work and now you're throwing something at me here? Well, it's pretty easy. Now, you'll have to work on memorizing this. The opposite of b, plus or minus b squared minus 4 times a times c all over 2 times a. Now keep in mind that a and b and c are those values right there in that particular equation. So for this one, which this particular example, okay, this particular example goes on along really well with example 2. So sorry I'm getting a little bit ahead of myself. I just picked these numbers a, b, and c and I didn't think about them, but this one goes along with example 2. Everything is set on one side of the equation, set equal to 0. That's one of the key points, is setting your equation equal to 0. If you get everything on one side of the equation set equal to 0, then you can use this idea of A's and B's and C's and plugging them in. So in this particular case, we have the opposite of 6 plus or minus the square root of 6 squared minus 4 times 2 times 1 all over 2 times 2. And so if I do a little simplifying, plus and minus, that part under the square root, 36, take away 8, that thing right there is 28. Okay, you know what, actually this doesn't go with example 2, this goes with, better goes with, let me find it. Well, actually this is a completely different example, so let me scratch this one. We'll call this, I don't know, this is just a plain example, I guess. But it has the same idea as example 1 and 2, so it's not that much different. Um, anyway, it's all over 4 there. So anyway, you may or may not realize how to simplify this, but inside of 28, there's a perfect square, 4. So I'm going to simplify this a little bit, and some of my students will see this right away, and some of you guys won't. So I'm going to split this up into two parts. You got negative 6 over 4, plus or minus. Now I'm hoping this doesn't cause any problems, but square root of 4 is 7, or 2, and then you've got your square root 7 sitting next to that. That's also over 4. And now you can see more clearly how to reduce this. Now, oops, sorry, radical 7 over 2. Sorry for the scribble there. It'd be nice if you could actually see it. See how you simplify each part, getting rid of a 2 from each fraction. Now, if you can immediately, another way to write this is negative 3 plus or minus the square root of 7 all over 2. That's another way to write it. I do not care which way you write it. It really doesn't bother me one way or the other. Okay, so don't feel bad about that. Example 1. Example 1 says 3x squared minus 5x equals 2, and they want you to solve this for x. I want you to keep in mind that it has to be set equal to 0, so you're going to have to swing that over to the other side through subtraction. So we have 3x squared minus 5x minus 2 equals 0. Oh, now you can do the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we got there 5 plus or minus the square root of, hold on a brief moment while I try to figure out where I wrote all this stuff down. There we go. We end up with 49 in here, right? You got a 25 minus a negative 24, and that gives you your 49. underneath this radical right here. All over 6. Now, when you have 5 plus or minus 7, because we know the square root of 49 is 7 over 6, I want you to understand something. 5 and 7 are both like terms. You can add them together. You can subtract them. So my two answers, I got 5 plus 7 over 6. That's 12 over 6, which is 2. And 5 minus 7 over 6, which is negative 2 over 6, or negative 1/3. So these are my two solutions. That time you end up with something that's a nice whole number or fraction, not something with the radical in it. Okay? So it does work out that sometimes you do need to continue down. I know I left my answer up here with the radical in it, but that's because those were not like terms. The example 2 in the book shows another type of problem. 2x squared equals negative 6x minus 7. Of course, you're going to be moving things over to the left-hand side, setting it equal to 0 so you can continue the process. Now we're going to go straight to that quadratic formula, right? Opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, right? Negative 6 over 4 plus or minus the square root of something over 4. What do we got there? 36 minus 56. That's a negative 20. Do you see it? I see it. Maybe you don't see it. Do you see it? I hope you see it. Yes, we got to take care of the I. So we got a negative 3 over 2 plus or minus. Oh yeah, this is the square root of negative 4 and the square root of 5. Anybody know what the square root of negative 4 is? Thank you. 2I. Whoops, looks like I left a 2 right in here. I better simplify that. Negative 3 over 2 plus or minus I radical 5 over 2. There we go. And like I said, you can write that as one single fraction all over 2, or you can write that as two separate fractions. It does not matter to me one way or the other. Example 3 we're going to skip. We're going to move on to example 4. In example 4, we're talking about something called the discriminant. So maybe I better back up and give you a little bit of a description about the discriminant before I get to that particular example. I think I'm going to get a new piece of paper here. On page 287, they talk about this thing called the discriminant, not to be confused with the determinant. The discriminant is equal to b squared minus 4ac. Okay, it is the part under the radical in the quadratic formula. Whoa, A, D. There we go. Okay, there is no radical. No radical in the b squared minus 4ac. That's only the part in the quadratic formula. But the discriminant itself is just this number. Okay, keep in mind we're talking about ax squared plus bx plus c. Now what's the graph of this look like? This is a quadratic. Therefore the graph looks like a parabola. We talked about that in chapter 5 section 1. There are 3 different situations that you're going to run across. Sorry, maybe that should be a capital T. Okay, the first situation. A parabola can cut through the x-axis twice. Keep in mind, when you are dealing with solving equations, solving quadratics, remember I kept saying to you, set it equal to 0? Well, keep that in mind. When y equals 0, you are really finding x-intercepts. So we are looking for these locations where it crosses the x-axis. So the first situation I want to talk to you about are 2 real solutions. There's 2 places where this particular parabola crosses the x-axis. Well, guess what happens when this situation occurs? The discriminant is a positive number, right? Positive number. Okay? But then we have the second situation where this thing comes down and it touches right at the vertex, and it could be like that or it could be like this, but it only touches in one particular point. So we have one real solution. Now, that particular situation, the discriminant actually equals 0. The discriminant equals 0 in this situation. And then the last situation is where it never crosses the x-axis. And in that case, so there are no real solutions. That's when the discriminant is less than 0 or a negative number. This situation causes something different to happen. We have two complex solutions. In other words, you're going to get I's in your answer. Okay? So look out for I when it comes to those situations. As soon as you see complex solutions, you know that the parabola never touches the x-axis. Okay, that being said, now we can jump into example 4. In example 4, they say, here's a particular equation. Tell me how many real solutions, tell me what type of solution it has. And so we're talking about real or complex. And tell me about the number of solutions. Okay? So it all comes down to this discriminant. B squared minus 4 times A times C. So we have 36 minus 32, which is 4. Well, that falls into the two real solution category, right? Because this is a positive number. As soon as I see a positive number, I know it's two real solutions. And so you can go back to those notes and determine which situation you're in that scenario. Now, example 5 gives you a real-life scenario of an object being launched. In this case, it's a field hockey ball. And they give me an equation of the ball flying through the air, and it looks like this. H equals negative 16t squared plus 34t. And you know that this is an upside down parabola, and the object's going to leave the ground and come back down to the ground. Okay? The question is they ask, will it reach 20 feet? Well, is 20 feet up here, in which case the parabola never reaches 20 feet? Is 20 feet right here, in which case it reaches one time? Is 20 feet right here, in which case it reaches once on the way up and once on the way down? Well, they're not asking. Okay, so we put the 20 feet in. We got negative 16t squared plus 34t. And now we can set this thing equal to 0, right? Swing the 20 over, because you can't use the quadratic formula or any part of it, which includes the discriminant, unless it's set equal to 0. So now we can say, all right, we got b squared minus 4 times a times c. That's all I need to figure out. And if I typed it in on a calculator, I get a negative 124. What does that mean? That's the situation where that's this one right here, right? No real solutions. Two complex solutions. So in other words, this ball will never reach 20 feet. Okay, you need to go to the notes, or go to the SurveyMonkey quiz, examples 1 through 5. So you should have 5 different questions that you're answering, and I just want you to tell me 1 through 5. 1 being I don't understand that example at all, 5 being I understand it completely, and I want you to rate how you did on, or how you understand these notes.